All right, so recording has started. It is September 28th, reaching the end of the month, which is crazy. We're flying by. It is Monday. Hope you had a great 3-day weekend. The plan for today, we're going to go over the Unit 1 assessment from last Wednesday. Okay, I haven't had a chance to grade everyone's at this point, but I wanted to go over it while it's still fresh in your guys' mind. We're not going to spend a whole lot of time on it. I'll answer questions if you have questions, but I'm going to go through it pretty quick today because you'll see my feedback in your packets or on Teams. So this is more so just so you can see what were the right answers, maybe where you went wrong. And then we're going to get into 3.5.2 unit fractions assignment on partitions. The target for today, it's the same as last Thursday. We're going to partition shapes into parts with equal areas and express the area of each part as a unit fraction of the whole. So again, like last Thursday, a lot of words in the target, but effectively what the target is saying is we're going to cut up rectangles into equal pieces. So 2 pieces or 3 pieces or 4 pieces, on and on. And we're going to represent what each of those pieces are in fraction form. Okay, so we're going to say this is 1/2. So this is 1/2 of the rectangle and so on. Homework for today. Unit fractions practice, that was from last Thursday. It's due tonight at midnight. And then I just assigned 3.5.2 partitions. It's page 8. It's not in your workbook. So don't go looking for it in your workbook because remember, we're kind of backfilling with some 3rd grade material before we get into the 4th grade book again. So this will be in your packet if you have it or on Teams, and it's due tomorrow night at midnight. Okay, so I'm going to stop sharing my screen. Let me get my first screen up. And my notes. Sorry, I had block 1 still up. I need to get to block 2. Okay. So plan here, or whoops. There we go. Now I'm in the right spot. So the end of the unit assessment. Okay, this is what we did last Wednesday. We're going to work through it fairly quick, but I'm going to stop at each question and allow you a chance to maybe ask for some clarification, etc. Maybe any help that you need. So the first question, or Camila, before we get started, do you have a question?
Is that page in the notebook or only in the packet?
This assessment?
Yeah.
So this was in last week's packet, not the current week packet. It was the very last thing in last week's packet. So you may have already turned it in, either in Teams form or in packet form. So you may not have this right in front of you, but if you follow along on screen, it's the exact same thing that you did already. So it's not new material or anything. Good question. Okay, what are the possible side lengths of a rectangle with area of 20 square units? So here, we're really just looking for factor pairs, right? We make our factor rainbow. We start with 1 and a number, always. So 1 and 20. Then we head on to 2. We know 2 times 10 equals 20. And then 4 times 5 equals 20. So these are our side lengths of rectangles that give us an area of 20 square units. So these were 3 options here. Okay, it wants us to sketch 2 different examples. So you can pick any 2 of those 3 and then do it. So I'm going to do the 2 by 10. I'm going to do a 4 by 5. Okay, you could have done any of those 3. Okay, so that's what you should have done, or something similar to that for this first question. You're finding the factor pairs that make 20, and then these multiplication problems that represent the side lengths, we can then sketch those as rectangles. Okay, questions on this first one? All right. Like I said, we're going to move kind of quick. You've already done this. I expect that you're just following along, maybe seeing where you went wrong, and then you'll have a chance to look at your feedback that I'll give you later on as well. So is 24 prime or composite? Show or explain your reasoning. Well, this is just finding factor pairs again. We know that a number is prime if the only factor pair is 1 and itself. So if we're trying to find factors for 24 and the only one we can find is 1 and 24, it's prime. But if we can find multiple factor pairs, then it's composite. Okay, so just like the other ones, we start with our factor rainbow. We have 1 and 24. Since 24 is an even number, we know that 2 will go into it. So if we skip count by 2 12 times, we will get to 24. So 2 and 12. We also have 3 and 8 as another one, and then 4 and 6. So we actually have quite a few factor pairs for this number 24. Since we have more than one factor pair, this is composite. Right, because we have more than one. If we only had 1 and 24, it would be prime. But since we have multiple, or 2 or more, it's composite. Now let's look at 29. Same thing yet again, make our factor rainbow and decide how many factors that it has. We have 1 and 29 to start off like usual. It's an odd number, so 2 won't go into 29. If we skip count by 2, we won't land on 29. We could try 3, but when we skip count by 3, we would have 27 and 30, so we'd skip over 29. If we were to skip count by 4, we would eventually get to 28 and then skip count and go to 32. So after trying all of these out, there actually is not another factor pair, just 1 and 29. So is this prime or composite? Well, it is a prime number because the only factor pair is 1 and itself, 1 and the number, 1 and 29. Okay, any questions on 2? Okay, I'm going to give a point to Camila and Katie because they are following along. I can see that they are, the camera's on. So Camila and Katie get a point for being on task. I can see them taking notes. And Elizabeth too. I have seen Elizabeth as well. So I'll give her a point for being on task. Nice work, girls. Let's go to 3. List all the factors of the following numbers. Again, just finding factor pairs. We make our factor rainbow and see how many factors there are. So for 25, we always have 1 and the number. So 1 and 25. Yeah, we could try 2 and we wouldn't have anything. We could try 3. We wouldn't land on 24. Same with 4. But 5 will work because 5 times 5 equals 25, right? So 5 times 5 equals 25. So our factors here, we have 1, we have 5, and we have 25. So there's our answer, 1, 5, 25. Now we can do the same thing for 18. We have 1, we have 18. So we can connect those. 18 is an even number, so 2 will skip count and land on it. And if we skip count by 2 9 times, or do 2 times 9, we will land on 18. If we skip count by 3 6 times, we will also land on 18. So those are our factors right there. 1, 2, 3, 6, 9, 18. That would be our answer. Okay, any questions on 3? Okay, let's go on to 4. One of the students in first block, the way that she answered this was multiplying 7 by numbers and knowing that the product at the end would be a multiple of 7. So she started with 1 times 7 equals 7. She made it easier on herself, so that's good. 7 is a multiple of 7 because 7 times 1 equals 7. She then said, okay, there's no point in doing like 7 times 42 or something crazy that you have to do a lot of math for. Let's do simple numbers that we know. Let's go to 2. 2 times 7 equals 14. So now we have 2 multiples. We have 7, we have 14. She then went on to 3. 3 times 7, that equals 21. So there's another one there. She then did 4, and 4 times 7 equals 28. And then 5 times 7 equals 35. So you could have different answers than that, 7, 14, 21, 28, 35. But the student in first class made it easy on herself and just made a multiplication problem out of it and used simple numbers, 1, 2, 3, 4, 5, to multiply by 7 and get us that answer. Eileen, do you have a question?
What page was this one and then the other one?
So this was the assessment from not this current packet, but the packet before. So it's page 36, 37 from the packet, but it wasn't in your workbook because it's a test.
Okay.
You would have only received it in the packet or on Teams. Okay. Select all of the true statements, looking at 5 now. 15 is a multiple of 3. Well, we can multiply 3 times 5 to give us 15. Now remember, this product here is a multiple of 5 and a multiple of 3. So A, saying 15 is a multiple of 3, would be a true statement because 15 as the product is a multiple of the 2 factors. And if 3 is one of those factors, then 15 is a multiple of 3. Okay, looking at B, 16 is a factor of 8. Well, let's look at this. 8 times 2 is 16. But the way that this is wording it is saying that 16 is a factor of 8, which is actually backwards, right? Looking at A, that we said was true, 15 is a multiple of 3. 16 would not be a factor of 8, it would be a multiple of 8, because we can skip count by 8 or multiply 8 by a number and get 16. So if factor was changed to multiple, it would be true, or if 16 and 8 were flip-flopped, then it would be true. But the way it's set up right now is false, so we'd leave it unmarked. C, the only factors of 49 are 1 and 49. Let's make our factor rainbow. We have 1, we have 49. Okay, we can try 2, and we wouldn't get there because it's an odd number, 49 is. We could try 3, but we wouldn't quite land on it. We land on 48, and then 51, but we'd skip 49. And we could keep going and going and going. And the only other number that would work is 7, because 7 times 7 is 49. You get that, Tania? So we have 1 and 49 and 7 times 7. So this, C, is actually false. It is not true, because this is saying it's only 49 and 1 for the factors. But we have 7 times 7. D says the factors of 12 are 1, 2, 3, 4, 6, and 12. Well, that is true. If we were to actually connect these together, there's our little factor rainbow, small little factor rainbow. So D would be true. And then 16 has an odd number of factors. Let's make our factor rainbow again. We have 1 and 16. And then we have 2 and 8. We have 4 and 4. So we have 1, 2, 3, 4, 5 factors. Those are 1, 2, 4, 8, 16. So therefore, 16 has an odd number of factors is true. Any questions on 5? Okay, let's look at 6. Yogurt comes in packages of 8 and in packages of 12. Lynn's school wants 60 packages of yogurt for a picnic. List 2 possible combinations of the yogurt packages Lynn's school could get and explain your reasoning. I only really expect 1 possible combination for this because we never talked about mixing up our packages that the products could come in. So really, I want us to focus on what is the 1 package or type of package that we can use and how many would you need. Tania, I need you to focus in on what we're doing here. Okay. So whoever is walking around you and talking to you and bothering you, let's have them go to a separate room or maybe have you move. So here we have packages of 8 and packages of 12 to choose from. And really what we're trying to do is figure out which one between 8 and 12 is a factor of 60, or which one has a multiple of 60, 8 or 12. Okay, so we could skip count by 8, but we actually wouldn't land on 60. But if we were to skip count by 12, we would land on 60. And it would take 5 skip counts to get there. So 12 times 5 equals 60 would be our reason for picking packages of 12. When we pick 5 of those packages to get 60 total. So there's one possible combination. We could also mix the packages of 12s and 8s, but we really didn't look at that. So this first one is really what I'm looking for. Okay, so any questions on this assessment here, on this problem or any problem in general? Okay, I see some thumbs up. Awesome. Let's go ahead and move on to what we're going to do today. So this is not in your workbook. Again, I can't remember if I explained it at the start, but we're reviewing some 3rd grade material still. So I want to make sure you are aware that this is not in your workbook. We'll get into workbook stuff maybe at the end of this week once we get out of this 3rd grade fraction review. So you've worked on this before. You've done these which one doesn't belong in the past. So no different for this one here. I want someone to explain to me, well, I actually want 4 people to explain to me, which one doesn't belong. Okay, looking at A, B, C, and D. Which one doesn't belong? And I want to hear from multiple people on this one. I'm handing out points for those who are involved in asking questions and answering questions. Jocelyn, let's go to you. Which one stands out to you as not belonging? It's different than the rest. C?
Yes.
All right, so why does C not fit?
Because it only has one shaded and the rest
Fucking badass, bro.
Okay, we have quite a bit of background noise. I think I picked up on what you were saying. Said that there's only one shaded, but there's multiple other cuts or multiple other spots that could be shaded, whereas the other ones only have one cut and either shaded and unshaded. Did I get that right? So I'm going to put multiple folds or cuts because those dotted lines, those dashed lines represent maybe a fold or a cut, marking off where the work is either shaded if we're trying to find the area or what's remaining, etc. So this is the only one that has 2 cuts or 2 folds. So nice job, Jocelyn. Camila, let's go to you. What's another one that stands out?
A.
All right, and why does A not belong?
It has a zigzag cut.
Okay, so it's a zigzag cut. Very nice. Whereas the other ones are all just a straight line, straight shot. Nice job, Camila. Camila's 2 away from hatching her Pokemon egg, so I think she might get it today. Very nice job. Let's go to, let's see, Adelina. Haven't heard from you much lately. How does B or D stand out?
B and D.
So choose one of them.
I would say that B has longer. B is longer than D, and it can fit 3 lines.
So there's another spot right there that they could cut.
Yep.
Yeah, that is very true. What do you know about the areas of the shaded region and unshaded region? Are they the same or are they different?
They are the same. No, they're different.
They're different. And what do you notice about the areas of D and C and A there? Are the shaded regions the same for every cut?
No.
No? So this spot on A, those two colored in areas, are those the same or are they different?
Oh, they're the same.
Yeah. And then what about C? Are each of those three pieces the same or are they different?
They're different. Those are different.
Those are different areas? The shaded region and then this piece there and that piece there? If we're only looking at C?
The shaded region is different from the not shaded region because they're shaded different. Because one of them is shaded and two of them are not.
That is true, but are each of those cuts the same area? So this first cut here in
Yes.
blue, yeah, that's what I was trying to get out of you. Nice job. So each of those shaded blue regions that I colored in are the same, right? Is that the same case for D? Each of those shaded regions are the same? Would you say so, Adelina? For D down here, the shaded and unshaded are the same?
They're the same, like, length.
Mm-hmm. Yeah, they actually have the same area. And then what about B over here? Is the shaded and unshaded the same?
No.
No. So this one has unequal cuts or area. Would you agree?
Yep.
Yep. All right. Nice job, Adelina. And then for D right here, who wants to help me explain why D does not belong? Tania?
D doesn't belong because it has a split down in the middle, kind of, and only one of them is shaded.
So it's split down the middle. It's going like left to right?
Yeah.
Yeah. So I'm going to say left, right, cut. So it's cut a little bit different. Very good job. Nice job, Tania. Nice job to the rest of you as well. Let's go to the next page in your packet and get your blocks out as well. And here's what we're going to do. This activity, fractions with pattern blocks, the yellow hexagon, which is not yellow here, I can maybe highlight it. Now it's yellow. The yellow hexagon is one whole. Okay, so that's one whole unit. That's what we're basing one off of. What number, aka what fraction, what fraction represents each other block? Be prepared to explain your reasoning. Okay, how can we represent each of these blocks as a fraction of this yellow hexagon? Any ideas? How many times can this trapezoid be used to get the entire area of the hexagon? I actually have this little thing here that might be able to help you. So if I have the yellow hexagon here, how many of these red trapezoids will it take to fill the entire yellow hexagon? Elizabeth?
I forgot to put my hand down.
That's okay. That's all right. I'm going to put everybody's hand down so I can kind of start over. Okay, so I'll ask that again. We're trying to figure out a fraction that represents each of these shapes. Okay, if yellow hexagon is one whole, so that's one whole unit, and we're trying to figure out what fraction of this yellow hexagon can we use to represent this trapezoid, we can ask ourselves, well, how many trapezoids will it take to fill the hexagon? Daniela?
2.
It'll take 2, right? I can even show you. If I were to take my 2 shapes there, there's a perfect hexagon using 2 trapezoids. So if I pull my notes up again, it'll take 2 of these guys to fill that. On Thursday, we talked about fractions. We talked about part over whole, right? So we have one part if we're trying to figure out a trapezoid, how many pieces it'll take to fit. So there's our trapezoid. If we were to move it over there and we said, okay, one of these would fill the top and we need another for the bottom. So I have one part there and there's 2 that make the whole, that take the entire shape. I'm a little delayed. It's taking its time. There we go. We have one part, if we're only talking about one piece, and there's 2 pieces that make the whole. So if we were to write this as a fraction, it would be 1 over 2. It'd be 1/2. Right? Does that make sense? Since it takes 2 trapezoids to make the whole hexagon, 1 divided by 2, or 1 over 2, 1/2 is what this piece would be represented as. So a trapezoid is 1/2 the area of a hexagon. What about this parallelogram, this little rhombus looking shape here, diamond shape? How many of the blue diamonds, the blue parallelograms, would it take to fill the entire hexagon? Eileen?
I have a question.
Okay.
What page is that?
And it's not in your workbook. It's in the packet, though. It's page 7 in the packet. Okay, so I'll ask this again. We did this for the trapezoid here. How many of these blue rhombus looking parallelogram shapes would it take to fill the entire hexagon? Araceli?
I say 2.
You say 2. So if I were to put one more on there, there's 2. Does it look filled?
No.
No. How many more do we need?
We need 2 more, but it's not the right shape where I could fill up the rest.
Well, could I take this blue parallelogram here and fit it right there?
Yes.
So how many blue pieces are there in total?
3.
There are 3. So in this case, let me redraw. Thank you, Araceli. If I were to redraw this like that, there's one piece right here. And we say that this spot and that spot would require 2 more of these parallelograms. So if we were to make our fraction again, we have one part and we have 3 that make the whole. So do you know how to say this fraction with words? Or can someone help me? 1 over 3. Camila, I see your hand just popped up. Do you want to help? How do we say that?
Are we going on to the next one, or are we still on the one that Araceli answered?
Still on the one that Araceli answered. I just wanted to know, how do I say this 1/3 as a fraction? We said that this one up here is 1/2.
1 part and 3 wholes.
Yep, so 1 part and 3 wholes. We could say that this is 1/3. Does that sound familiar?
Oh, yeah. Yeah, it does.
1/3. Because we have 1 on top and we have 3 on the bottom. So 1/3. 1 on top, 3 on the bottom. Okay, so this one, we said 3 pieces make the fill the shape. So 1/3. Okay, Camila, did you want to help with the next one?
Yeah.
Okay, so how many, let me get my screen shifted back over here. How many triangles would it take to fill that shape? And you can try it with your manipulatives too.
Four.
Not quite 4. If we were to do 4, it could look something like this. Do you want to phone a friend?
Yeah.
Elizabeth, you're going crazy down there. Let's hear it. What are you thinking?
6.
Yeah, it would take 6, wouldn't it? Let me get this last one. Flip just right. There we go. Yep, so 6 total triangles would make the entire area of 1 hexagon. So let me get this back over here. Elizabeth, do you want to help me write this out as a fraction? How many parts are there if I'm only looking at 1?
1, 6.
Yeah, great job. We have 1 part. We have 6 that make up the entire whole. So 1/6 would be our answer. So a triangle is 1/6 of the hexagon. Nice, nice job. Are there any questions here? No questions at all? Okay, so here's what we're going to do for homework. This was posted on Teams right before class. It's in your packet if you picked up packets. It says partition each rectangle, or cut/draw a line to separate into equal parts. Partition each rectangle into 2, 3, 4, 6, or 8 equal parts, depending on what it says. There's a few options here. Then label the size of each part with the correct fraction. So let's look at this first one together. If I were to cut this first part, or this first rectangle, into 2 parts, where would I need to draw my line? Camila?
In the middle?
In the middle like this?
Yeah, like that.
Okay, thank you. We're then told to label the size of each part with the correct fraction. Camila or anybody else, what is the fraction that represents each of those 2 pieces? Let's go with Eileen here. Camila just earned a point. I want to spread the love around. Eileen gets a point too. What is each of these pieces in fraction form, Eileen? Looking at this rectangle here, the one that's cut into 2 parts. We said we had parts on top over whole on the bottom.
Mhm.
So if I'm looking at this piece right here, how many parts are there? How many of those pieces are there that are shaded?
1.
Yep. So one part is shaded. How many parts are there that make the whole? How many pieces are there?
2.
2. So each piece is what?
1/2.
Yeah, 1/2. All right, we have 2 parts that make the whole, and we're only looking at one of those parts. So 1 part to 2 that make the whole, 1/2, 1/2. So I want you to do this for each of these rectangles. There's one for 3 parts, 4, 6, and 8 parts. And that's all you're doing for the homework, okay? You're just cutting up those rectangles, not literally, not taking scissors, but you're drawing the lines to separate into equal pieces and writing the fraction that makes that each of those pieces represents. All right. Any questions on what's expected of you on the homework?
No questions.
Okay, I'm going to stop the recording real fast.